For this video, we will be factoring a monomial from a polynomial. So the procedure for this is pretty simple. For each one of the polynomials, we're going to be finding the greatest common factor. And then we're going to use the distributive property backwards to pull this greatest common factor out of the polynomial. So if we look at a problem like this one, we've got 16x to the fifth plus 24x cubed plus 84x squared. So we want to look at this and we want to think, what is the greatest common factor here? Well, if we look at this, if we break it down, 16x to the fifth, that's 4 times 4 times x times x times x times x times x. 24x cubed, that's 4 times 6 times x times x times x. And 84x squared, that's 4 times 21 times x times x. So we want to figure out what is our greatest common factor here. Well, if we go through and look, we've got, in each one we have a 4. And then we've got some x's in each one. Well, let's see, I've got 2 x's in my last term. I've also got 2 x's in my first term, 2 x's in my third term. So my greatest common factor is going to be 4 times x squared. Alright, so now to use the distributive property, we just go through and we multiply out whatever's left. We have 4 times x squared times, in our first term, 4. We've got 3 x's left, so 4x cubed. In my second term, I've got 6 and 1x, so 6x. And in my third term, I've got just a 21 remaining. So there we go. We've factored it out. We've found our greatest common factor, 4x squared, and we've simply used the distributive property backwards to pull that out of all of the terms in our polynomial, and then we write it like this. 16x to the fifth plus 24x cubed plus 84x squared is the exact same thing as saying 4x squared times 4x cubed plus 6x plus 21. So let's look at another slightly more complicated example. Here we've got 3x to the fifth y cubed plus 9x squared y to the fourth minus 12x cubed y squared. We want to figure out what is the greatest common factor of these three terms. Well, if we look, we've got 3, 9, and 12. And we think, what's the biggest number that is a factor of all three of those? We think that that is 3. These are all powers of 3. And then let's look at our x term. X to the fifth, x squared, x cubed. Well, the easy way to figure this out is we simply go, which is the smallest power of x that we've got? Well, x to the fifth, x squared, x cubed. Here we go, x squared. So x squared is going to be our greatest common x factor. Do the same thing with y. I've got y cubed, y to the fourth, y squared. Well, here we go. Y squared is our smallest power of y, so y squared is going to be our greatest y factor. Now we simply do our division and pull them out. 3 divided by 3 is 1, so that disappears. X to the fifth divided by x squared gives us x cubed. Y cubed divided by y squared gives us just a y. Then over here, 9 divided by 3 is 3. X squared divided by x squared is 1, so those disappear. Y to the fourth divided by y squared is y squared. Minus, let's see, 12 divided by 3 is 4. X cubed divided by x squared is x. Y squared divided by y squared is simply 1, so they cancel out. And we are left with this as our simplified answer. 3x to the fifth y cubed plus 9x squared y to the fourth minus 12x cubed y squared is the same as writing 3x squared y squared times x cubed y plus 3y squared minus 4x. That's all we have to do. Find the greatest common factor, and then use the distributive property backwards to factor it out of the problem. So here is your try it problem for tonight.